Welcome to lecture 12. In previous lecture we seen about the what and all PV module containing, how many layers of PV module having, like backsheet, about junction box, and what and all material required for manufacturing the PV panel. That and all we have seen. So in this lecture we will see about the understanding the PV module and PV module data sheets and alternative PV module design. That and all we will see in this lecture. So welcome to lecture 12. Myself Karthikyan. Let's see the lecture outline. In this lecture you will know about the overview of PV module manufacturing process and how we will do manufacturing quality checks, comparison of automatic and manual PV assembly line, understanding the PV module datasheet, cell to module losses, and alternative design of PV modules. That and all we will see in this lecture. First we will see overview of PV module process. I already told in the last lecture, so we will just go through that one. First what we will do, we will start the glass cleaning. In order to put glass on the solar cell, first we have to clean that glass. Then we have to use EVA meter to cover that solar cell, that is called EVA cover sheet. Then we have to do layup. What is the layup? It is nothing but placing solar cell in a certain manner with particular distance to get a complete module. So layup is nothing but placing the set of series solar cells. Next step, we have to solder each terminal of the solar cell. Then next what we have to do after the this connection, we have to put another cover sheet. Then after that we have to put back sheet. Then later we have to do laminating of these two sheets. Then later we have to trim the edges. In order to getting the high sharp edges, we have to remove that one. Later we have to put framing to give the strength to solar module. Then later we will attach the junction box. Then final we have to do inspection whether it's like junction box are correctly placed, whether frames are correctly attached, whether any mismatch in the connection, that and all we have to see. So finally we will get the finished solar PV module. Then what and all the quality checks we can see. So same process we have to know, but where we have to do the quality checks, first we will see. So this is the same process will be going on. While soldering, we have to take first verified process. First of all, you have to check whether placed solar cell are correctly placed or not. Then whether bus bar are correctly connected or not. Then how soldering has been done and what are the interconnection. Is there any mismatch? That and all we have to see. That is verification in the step 4. So next we have to see at the step 6 how backsheet has been attached. Whether is there any fault in the backsheet, is there any fault occur, whether it is possible to remove faulted cell. That is the main steps. Then laminating, it is one of the delegated process. We have to do this laminating very carefully. If laminate will goes wrong, entire solar panel will be go fault only. I will tell you later what and all. So after the laminating process, we are just trimming and framing and junction box. Then finally we have to do inspection. There will be a thermal inspection. We have to check whether crack is there or not, whether everything are placed right or wrong. That and all see. Then finally we have to check the module characteristics, basic IV curve. What is the expected voltage we have to get, whether we are getting the same voltage, same short circuit current or same open circuit voltage in the laboratory condition. That and all we have to test. See in the inspection, that is we have marked as a red line. So while some crack will occur that can be detected while placing the backsheet only or laminating process. If something goes wrong in the process design, we have to check. This is called electroluminescence imaging. Okay. So in step 6, step 7 and step 11 we have to do electroluminescence imaging that will get a black and white image. So in this image we will clearly get the any crack in the cell or any problem detected in the cell, that and all we have to do. So V means voltage checking. So while placing whether I am getting the sufficient voltage or not, that we have to check. That is at the step 4, step 6 and step 9. Finally we have to get IV curve, whether I am getting the exact IV curve as we have designed earlier of the solar cell. So we will see how solar PV or module are manufactured. There will be two lanes, that is called automatic line or manual PV assembly. In automatic what happens, starting to end everything is done in the machine except soldering of the bus bar. Now in some cases even bus bar soldering also done in the machine only, but in manually we have to do soldering by hand and attaching the frames, that is also by hand, that is the manual assembly. So we will just see the comparison how much efficiency it is there. So first we will see the what is the quality of that PV panel. If I process done in the automatic line, that is high quality with a good quality. In manual line there may be chances of default. And control, how we can control the process, that is also high. Whenever something goes wrong we can stop at a time, but in manual it is difficult. For investment, how much investment we have to put for this manufacturing. So for automatic manufacturing, there will be investing cost. Cost is very high. In manual, there will be low cost. Electricity consumption, because automatic containing all the same line with a limited number of electrical system. But in manual, we require more number of electricity. And repair and maintenance. In automatic, it is difficult to maintain the systems, but in the PV manual assembly it is easy. Flexibility, because it is not flexible that much in the automatic system and it is very flexible in manual system. So we will see the understanding what is the PV module data sheet, what it is containing. Okay, first they are providing the specification. What is the cell? Which type of cell they are used? That is either monocrystalline or multicrystalline. Okay. Then what is the weight? Total weight of the module. That is 22 point kg in this scenario or plus or minus 3%. And total dimension of this module, that is they are giving. And cable cross section size. What is the cross section size of the cable, because it should carry the current much larger way, so that's why that is 4 millimeter square. And number of cells, so I generally told that there are two type of POV module, either which containing 60 cell modules or 72 cells. In this module containing 72 cells. And junction box, whether it is water resistance, how many diodes it containing the junction box, that and all they are giving. This is IP67 rated. Then connectors, MC4 connector, that voltage rating is 1000 volt. Then packing configuration, that is called 27 per pallet. That much module they are packing. So operating condition, what are the operating condition? So at what voltage it will operate? It will take maximum system voltage. See, this is the system voltage which containing it probably around 30 to 40 panels. The maximum is 1000 voltage. So even single panel also capable of handling 1000 voltage or 1500 voltage DC. Then operating temperature, that is 40 degrees Celsius to 85 degrees Celsius. Then maximum series fuse, how much current it can be handled, that is 20 ampere. After that, maximum static load, that is 5400 Pascal. Then maximum static load at the back, how much? 2400 Pascal. Then NOCT condition. This is given as a inside the test laboratory, that it can be handled 45 degrees Celsius standard. I already told that there will be two conditions. One is standard temperature coefficient and NOCT condition. This is number of temperature coefficient in the laboratory condition. In standard STC condition, it can handle and design for 25 degrees Celsius and 1000 watt per meter square irradiance. For NOCT condition, it can handle 45 to 47 degrees Celsius. Then application is a class A application. Another set of the PV module datasheet containing, this is in another end. If you get the module manufacturing done, while installing you will get this kind of data sheet. What it containing? This this is nothing but electrical data sheet. Previously we seen the module data sheet. It does not containing any electrical parameters. It is only containing the some general parameter like weight, temperature and all. Here we will see electrical parameters. In electrical parameter, it is at a STC condition, standard temperature coefficient condition. What is STC? It is at 25 degrees Celsius and 1000 watt per meter square. What is the rated of this PV panel? How much rating it has been designed? So these are the different solar panel. One may be JM S01, another one is JM S01 for 355 watt, another for 360 watt, another for 365 watt, another for 370. Like this they have designed. For 355, what is the open circuit voltage? That is 47 volt. So in this case the number of cell containing, it may be a 72 or more than that. And what is the maximum power voltage? That is 38.76. What is the maximum power that is occur in this point? See here, my cursor is showing here. This is the maximum power point. Here only I will get the maximum voltage and maximum current. Then short circuit current 9.69. Here I will get the short circuit current. Then maximum power current, that is 9.16. That is also get here 9.16. Then module efficiency. You know how to calculate the module efficiency. That is output power divided by input power. Then tolerance, that will be a power maybe during some condition it may go up to plus or minus 5 watt. In some extremely high intensity there will go plus 5 watt extra. So similarly for 360 watt module, similarly for 365 watt module, that and all you will see. Then also they are provide the IV curve, current and voltage curve. What is the current for the 1000 watt per meter square intensity? What is the voltage? Then what is for 800 watt per meter square, 600, 400, 200? Then similarly they are also providing PV curve, how much maximum power I will get at the 1000 watt per meter square. Here I will get the maximum power. When it is reaches to 800, it will give here, it will give here when intensity will decreases. These are the basic electrical parameter of the PV module. So we will see the temperature effect to the PV module. We already knows that when temperature will increases, voltage start decreasing, also current starts increases. So by this method we will get some temperature coefficient, that is called ISC. The temperature coefficient of current ISC is called as a alpha. Temperature coefficient of voltage is called it as a beta. Then temperature coefficient of power, it is called gamma. What is that temperature coefficient alpha rating? That is usually for all the module it is around 0.06% per degree Celsius, and for beta it is minus 0.3% per degree Celsius, and for gamma it is minus 0.380% per degree Celsius. So while calculating we have to consider power with percentage. So like this we will see the temperature effect on the PV module. So now we will see what are the NOCT parameter. What is the NOCT? That is nothing but nominal operating cell temperature. So it is typically given in the data sheet. They are giving the STC condition as well as the NOCT condition. So for NOCT electrical parameters are, see, first of all we will see how many power rated solar panels are available. That is 355, 360, 65, 70, 75. Then NOCT value of power will be 261. What we previously seen, that is the STC value. Here we can see the parameter. In NOCT parameter we will get the power max will be 261. In their case there we are getting 355, that is STC condition. So similarly VOC is 43.88 and VMP is 35.81. ISC short circuit current is 7.68 and maximum current is 7.29. And NOCT condition, how it is applicable for this one, irradiation should be 800 watt per meter square. For STC condition it is 1000 watt per meter square, and temperature here 20 degrees Celsius. For STC 25 degrees Celsius. And we no need to take about air mass, this is around 1.5. For their air mass is 1 and wind speed 1 meters per second, that is and all constant for STC and NOCT condition. So now we have to see about how much warranty it will give, what and all certificate it is required. So what type of warranty we will get? First we will get the superior warranty, that is 12-year product warranty. Then 25-year linear power output warranty. What is this? This is, we are getting the product warranty for 12 year. Okay. Then linear power warranty. It is nothing but suppose we consider previous case. I am getting 355 watt panel. Okay. So in this case, they are telling that after 5 years, this much degradation should be happening. After 10 years, like this, if degradation will be go beyond that one. Suppose now warranted power is 355. Okay, then after 5 years it reaches to 345. Then okay. Then after 10 years it is reaches to 340. It is fine. I can consider. But suppose if I get the warranted power within the 5 years 355 to directly 300, then we have to claim for the warranty. Then these are the certificates and required for the manufacturing, that is IEC 61215, IEC 61730, UL 1703. These are the certification required after module manufacturing. So then what type of quality management system we require? That is called ISO 9001 and 2015 quality management system is required. Then environmental certificate, that is 14001 to 2015. Then that are the other certificate also we have to take consideration. So by eligible for the all this certificate, then only we can manufacture the solar module. So after manufacturing of the module, it should eligible for the all this certification. So if you want, you can see detail in this certification detail, like what is exactly IEC 61215 gives. In basically I will tell you the this IEC 61215, it will tell that for this module, for this certification, this much current should be there, this much degradation should be happen within the 10 years, then only it will eligible for the certification. This is one remark thing. Electrical data in this catalog, it is not referred to the single module. So basically whatever we have plotted, it is not referring only single module, it containing the several module, and they analyze the different module types, then only they compare the this type of warranty diagram and certification. So we will see how we can convert cell to module. Generally module efficiency should be less than the cell efficiency. Why? Let's see. Module power is divided by individual cell power, that is always less than 1. So what will happen while manufacturing, we are getting 20% efficiency of the solar cell, but while attaching and series connection of the solar cell, there may be chances of 0.1% of degradation in the efficiency. So that's why while we getting the solar module, the efficiency whatever we are getting, it is much lesser than the cell efficiency. So if you want to get that ratio, you will calculate with the module power divided by individual solar cell power. So suppose if I get module power is 255 or 355, I will get one solar is zero point 0.6 into 8 ampere, that is around 4 watt, 4 to 5 watt. If I add all the 355 rating, so for 355 power I will get around 72 cell. So I will add that 4 watt to 75 series, I may get more than 355 watt. So 355 divided by, let's suppose 360, that should be less than 1, it is a ratio. So that's why almost all the time we will get the less than 1, that may be 0.5 to 0.9. Then this is just a paragraph of the different type of losses. So cell to module losses. First we will see what are the cell losses. Basically we already know that there may be a more number of optical losses, then optical gain. Then later in the module there will be a electrical losses, that is much higher percentage. Then we will know the what and all containing in the x-axis, that is a cell power, glass reflection, glass absorption, reflection, encapsulation, absorption, shading of the ribbon, coupling cell surface, coupling fingers. This and all containing the losses. There will be a some small amount of losses will be occurring. So if we consider these things in a module, there will be losses occurring in the module is more comparing to the solar cell. So this is one of the different alternative design of the module. So here what they are making, they are using dual glasses. There will be small thin glasses, but it containing the dual at the both the side. This will produce the higher reliability and lesser cell cracking, and very less moisture are going through in it, because few solar panel are having some amount of moisture, but using this dual glass technique there will be 0.01% of moisture is going inside that. Also it is very difficult to see the cracking of the cell, then it will be gives high reliability. Then also it is prevent from the acetic acid corrosion, higher weight and corner chopping. That and all we can do. And another thing, dual glass plus bifacial. So dual glass is nothing but we seen that there will be two glasses. Then what is bifacial? In bifacial it will take energy from the both the side. So, because generally what happen in solar module, there will be solar cell and it containing the back sheet, and after the back sheet I will get the junction box, and the solar run sun rays is coming only on the one surface. But in bifacial we have to put solar panel such a way that it will get sun rays from both the side, so it will collect all the rays in the both the direction. So that's why it is called as a bifacial model. So it conducting on the both the side, then all the sun rays will be coming on both the side. Suppose morning I am getting the sun at the east side, and evening there will be a sun at the west side. So that time I will get the maximum power at the both the side. So in this case, what is the benefit? First of all, it is producing high energy yield, and it is the benefit due to the dual glass also. There will be a less breaking of the cells, and there may be a sometime partial shading effect can be obtained. There will be sometime. Then, but one chances is that by placing vertical, there may be a chances of breaking. Like entire module is fell down. That may be a chances. That are the some drawbacks. So another thing is a flexible module. You can see it can be tilted in a different way. If suppose I want to put that in my rooftop or in my surface of my car, I can be use that flexible solar cell. These are the benefits are it is flexibility good for the application. But what are the drawbacks? Here there may be a chances of there may be a okay chances of cell cracking. Then there will be a transparency effect will become discoloration. What will happen? Then front sheet may be breakdown. Some because we don't know how much bend it can be done. Sometime what will do, we know that this module is flexible, so that's why we will bend much more. So due to that thing it will damage, but it is also good solution for the flexible kind of thing. If somebody want to use his roof of a car, like I want to just charge my mobiles, I want some energy, so in that case they can put this flexible solar panels. Then this is a cut cell. This is nothing but there will be a small cell. So we know that there will be a one standardized cell that it is in a monocrystalline and multicrystalline, but in cut cell there are a very tiny cells are attached together. So in tiny cell what will produce, it will produce higher voltage and losses will be very less, but it will be produce the cell cracking, and it may require additional bypass diode, and it is difficult to do the processing of manufacturing. So that and all difficulties will come, but generation wise it is giving good electrical power. So in this case we have seen what are the datasheet containing, what are the electrical parameter, what are the STC condition, what are the NOCT condition, that and all we have seen. So in next lecture, we will just briefly see the why we want to use bypass diode, how actually cells are placed, and how module are put in the solar plant. That and all you can see in next lecture. Thank you so much.